All right, hi, this is your quiz review for Unit 2. So the first one says slope of the tangent line. That means derivative, so we're going to find the derivative, and then we're going to plug in -2. And so the rule that you would need for this one is quotient rule. It's going to be denominator times derivative of the numerator, which would just be 1. You can write that or not, minus the numerator times derivative of the denominator over the denominator squared. And then we are going to just plug in -2. And you want to be careful to do these on two separate lines. Do not put an equal sign here and then start plugging in the -2. That is what's called a linkage error. This is the derivative in general, and then this is the derivative at the specific point for x equals -2. They are not equivalent things. So do not put an equal sign and keep going. Make sure you do it on two separate lines. All right, so if we plug in -2 here, that's going to be -6 plus 1, that would be 5. Here we would have -6 times 3 would be -18. So it's going to cancel out those negatives, make it a +18. And then down here, again, we'll have -6 plus 1, -5 squared would be 25. So what is that? 23 over 25. All right, equation means that you need a point and a slope. We're going to do this at x equals 25. So to get the y value for my point, I'm simply going to plug in 25. So square root of 25 is 5, times 3 is 15. 7 minus 15 is going to be -8. Your slope is going to come from the derivative. So we're going to do a similar thing to what we just did up here. 7 is a constant, so that's going to be gone. And I try to get everybody to just memorize the derivative of square root. It's 1/2 square root. It's better to just know that than have to deal with all the 1/2 and the -1/2 exponents and everything. It's just 1/2 square root. It's just we have a -3 in there, so it's going to be -3/2 square root. And then we're going to plug in 25. Square root of that will be 5, times 2 is 10, so -3/10 is our slope. And then we're going to just put it all together into our equation. It would be y minus -8, so y plus 8 equals our slope, and then x minus 25. All right, all the rest of these are just find the derivative, and I don't need you to simplify them except for this one. I want to get rid of the negative exponents. But for all these, we're going to just find a derivative. So this one is just power rule. You would multiply the 12 down. 1/4 of 12 would give you 3. Subtract 1, you get 11. 8 is a constant, so that's gone. This one I'm going to rewrite. It's x to the -7th is what that means. So when we do our derivative, we're going to bring down the -7. When you subtract, it becomes more negative, so it's going to become a -8. And then, again, the directions say to fix the negative exponents so that x to the 8th goes back down to the denominator since it's a negative. All right, this one is going to be a chain rule. We're going to bring the 6 down. The insides are going to stay the same, and it's going to drop to a 5. So we did a power rule with the part outside, and then we're going to chain on the derivative of what's inside, which will be -2x. The 9 is a constant, so that is going to go to 0. And so just power rule on that -2x. All right, this next one, I hope I have enough room. I'll try and write small. It's going to be both a product rule and a chain rule. So you have a product rule with this is your first function, this is your second function, and then within that you have a chain rule on this one. And actually, I know I'm not going to have enough space, so I'm gonna come down here and make it so I have enough room. All right, so it's going to be the first function, so the 2x minus 3 to the 5th. Derivative of the second would be 7, plus the second function. And then here's where the chain rule comes in. We're going to do derivative of the first one. So I'm going to bring the 5 down. The insides will stay the same. It drops to a 4. And you chain on the derivative of what's inside, which would just be 2. Again, I don't want you to try and simplify that at all. Just please leave it alone. If you do try to mess with it and end up making it wrong, then I have to mark it wrong. And also, it's more work for me, so please just leave it alone. All right, this is a chain rule with 3 links in the chain. The first one is the power of 3. The second one is the cotangent, and then inside of that is the 2x to the 5th. So first we're going to do the power. Bring the 3 down, drops to a 2. Everything else stays the same. So we just did a power rule. Now we're going to do the derivative of cotangent, which is negative cosecant squared. And again, the inside stays the same. And then we're going to chain on the derivative of what's inside the parentheses. So derivative of 2x to the 5th would be 10x to the 4th. I'm going to do the same thing I did up here and kind of move over to the side so that I have enough space. This is going to be a quotient rule and then also a chain rule because you have secant of more than just x. It's secant of 3x. So starting with our quotient rule, it'll be the denominator and then derivative of the numerator. So derivative of secant is secant tangent. And then we're going to chain on the derivative of what's inside. So derivative of 3x would be 3. So it's denominator, derivative of the numerator, minus the numerator times derivative of the denominator, 9x to the 8th, over the denominator squared. Again, don't simplify anything. Just quizzing you on, can you find a derivative and do you know all the rules? Right? This one's going to be a product rule and a chain rule. So your first function is e to the 4x. That'll involve a chain. Second function is sine of x. So product rule, we have the first function, derivative of the second, plus the second function, and then derivative of the first. Derivative of e is itself, and then we chain on the derivative of 4x. All right, 10 is just a chain rule. It's going to be e to the power of all of that stuff. The derivative of e is itself, so just basically copied the problem. And then we're going to chain on the derivative of that stuff, which would be 12x plus 2. I guess I would have had enough room for that one. All right, 11 is also a product rule and a chain rule with that cosine cubed. So product rule, we're going to start with the first thing. And then derivative of ln is 1 over x. So first times derivative of the second plus second function, and then derivative of the first. This is where a chain is going to come in. Your outside function is the cubed. So we bring the 3 down, drops to a 2, and then you chain on the derivative of cosine, which is negative sine. So your product rule, first function, derivative of the second, plus second function, derivative of the first, which again involved that chain rule. That one was similar to this one. Like if this was just cotangent cubed of just x, but this one had like a third link in the chain. Whereas that one only had 2. It only had the cubed and the cosine. It's just x. If it had been like, I don't know, 5x or x cubed or something, you would have had another chain rule there. All right, and then last one. This is not a product rule. That's a really common mistake I get there. If it was ln x times what's in the parentheses, then it would be a product rule, but this is just ln of all this stuff. So derivative of ln is 1 over whatever is there, and then you chain on the derivative of that stuff. So 24x squared plus 6. You can also write this in the numerator. I'm just illustrating the chain rule there.